Why did the cat fall off the roof? He lost his mew.
Don't understand this joke? Please continue watching this video and the secrets of the frictional universe will be revealed to you.
Hey, Jill, you want to pass me the book?
Sure. Wait! Stop right there! There's static friction acting on this book.
What's static friction?
There are two types of friction, static friction and kinetic friction. Static friction is the force that keeps an object stationary. It must be overcome before an object starts moving. When you zoom in close to an object, it actually has tiny grooves. When an object is experiencing static friction, the grooves are interlocked.
Regardless of whether a surface appears to be smooth or rough, it still has tiny grooves.
Once you push the object with enough force, the grooves are no longer interlocked and the object begins to move with less force being pushed on it. This is known as kinetic friction.
Now I see the book be pushed with enough force to overcome the static friction and slide across the table.
Hey, Jill, you want to pass me the book?
Sure. Another example of overcoming static friction is when you're wearing socks while you're walking on a smooth floor and you start to slip. If you scuff your feet rather than firmly planting them on the floor, there is a greater chance that you will slip when you overcome the static friction due to the decrease in the normal force.
So what is the normal force?
Have you ever noticed how if you push down on an object and pull up on an object, the force of friction is different? This is because if you have an object and you push and the applied force is only in the x direction, the normal force will be equal to the force of gravity. But if you push down on an object, you still have the force of gravity, but then you also have the force applied. This means that the normal force, in order for the force in the y direction to be equal, the normal force must be larger. Which means that the normal force equals the force applied plus Fg. But if you pull up on an object, the force of gravity is still the same, but if you pull up on an object, the normal force can be smaller because, once again, the force in the y direction must be equal to 0. Then you get Fg equals Fn plus F applied. The reason the normal force is important is because of the amount of space that would be left between the grooves. In the example where the applied force is downwards, there's more pressure. There's more pressure between the object and the surface that it's moving across, that it will take more force to push across it, like this. While in this example, because there's less pressure, then there's more space, so it takes less force than this example to push across to overcome the friction.
The equation for finding the frictional force is the force of friction equals the normal force times mu. And mu is the coefficient of friction. Depending on whether you're finding static friction or kinetic friction, you'll use a subscript S for friction and mu, or a subscript K for kinetic. And every surface will have a different coefficient of friction for static and kinetic friction. Right, so how does the magnitude of the normal force affect the force of friction? Well, since the normal force is proportional to the force of friction, if you increase the normal force, that means it's going to be a greater force of friction. Like in the example, if you also had an applied force pushing down on the surface, and the normal force would be greater, the force of friction would be greater, and you would need more of a horizontal applied force to overcome it. Similarly, if the normal force was smaller, the force of friction would also be smaller. So if you had an applied force acting upwards on an object, you would need less friction to get it moving in a horizontal direction. Friction is everywhere. We have already discussed the example of sliding a book across a table, but you can also measure the force of friction when sliding a stool across the carpet, or even as a bunny jumps across the floor. But right now, let's examine the forces as a mini fridge is pushed along. So now we're going to solve to find the force of friction that was acting on the fridge as it was pushed across the carpet. So here's our free body diagram of the fridge on the carpet, and we know that there's force of gravity acting on the fridge, as well as a normal force, and an applied force, which was 25.0 newtons, and it was applied at an angle of 20.0 degrees above the horizontal. This fridge has a mass of 15.0 kilograms, and the coefficient of kinetic friction, because the fridge was moving, is 0.146. So the first step that we need to take to find the force of friction is to find the x and y components of the applied force. So using trig ratios, we know that F applied x is going to be the F applied, which is the hypotenuse, times the cosine of 20.0 degrees, which is equal to 25 newtons times cosine of 20.0 degrees, which is equal to 23.492 newtons, and it's in the positive direction going this way, to the right. And we're going to leave this value unrounded for further calculations. So it's the same thing for the F applied in the y direction, except we're going to use the sine ratio instead. Sub in the values, 25.0 newtons. Oops, not cos. Sine 20.0 degrees. This is equal to 8.551 newtons. And we defined up as negative, so that means this value is going to be negative. Now we can find the force of gravity acting on the fridge. So this little equation, mass times acceleration due to gravity. So we'll sub in the mass, 15.0 kilograms, times acceleration due to gravity, 9.81 meters per second squared. And this value is 147.15 newtons. And it's going down, so we can leave it positive. Now, we know that the net force in the y direction is equal to 0 because the fridge didn't move up and down, it only moved side to side. So then we can calculate the normal force because we know that the net force in the y direction is equal to the force of gravity plus the normal force plus the force applied in the y direction. So rearrange to solve for the normal force, and you have Fn equals F net y minus Fg minus F applied y. Sub in 0 newtons minus 147.15 newtons minus, and now the F applied y was a negative value, so minus negative 8.551 newtons. And this is going to equal negative 138.599 newtons. And now, finally, we can find the force of friction, kinetic friction, using that formula we learned, Fk equals Fn times mu k. So if we sub that in, we have negative 138.599 newtons times 0.146. And this equals negative 20.235 newtons. And now, since this is our final answer, we can round it to 3 significant digits to approximately negative 20.2 newtons. So now we know that the force of friction is going to the left at 20.2 newtons. And there you go. That's how you find the force of friction acting on an object.
We know physics can be a drag.
But it's really not that bad.